Good morning, students. During the last episode, we discussed about the physical properties of metals and non-metals. The physical properties. What do you mean by physical properties? Physical properties means its color, shape, hardness, melting point, boiling point, etc. as known as physical properties. We have listed a number of physical properties like all metals are hard, they have high melting point, high boiling point, good conductors of heat and electricity, metals are malleable, they are ductile, they are sonorous, they are lustrous. Similarly, we have studied the physical properties of non-metals. First of all, before we are going to study the physical properties of non-metals, you have to point out some examples of non-metal. Can you point out some examples of a non-metal, a typical non-metal? It is familiar to you. Carbon, a typical non-metal which are familiar to you. Carbon means coal. It's a coal or coke. Similarly, sulfur, they are non-metals. You have studied the physical properties of non-metals also, but in exam point of view, what you remain is there are some metals which shows exceptional properties to the general properties. That is, you have to remember for the exam point of view. For example, all metals are hard. All metals are hard. Can you point out? Can you say any metal which is not hard? Yes, sodium and potassium. Sodium and potassium are soft metals. Soft metals. Sodium and potassium have some properties. They show some exceptional properties. You have to remember in your mind that sodium and potassium, they are soft metals. That means it can be cut with a knife. Like copper, it can be cut with a knife. The sodium and potassium are kept in kerosene. Why? It is highly reactive. Sodium and potassium are highly reactive. It reacts with oxygen and moisture present in the air. It reacts oxygen and water. So it cannot be kept in air. It cannot be kept in water. If it is kept in air, if sodium and potassium are kept in air, what happens? It reacts with oxygen and moisture. If it is kept in water, it is highly reactive, it reacts with water. So, they are kept in kerosene. Similarly, all metals are solid. The only liquid metal is, do you know what is mercury? Yeah, what symbol? Hg. When it is used in thermometer. Similarly, all the non-metals also shows some general properties. On the reverse, metals are hard, non-metals are not hard. Metals are malleable, non-metals are not malleable. Metals are ductile, non-metals are non-ductile. Metals are lustrous, non-metals are non-lustrous. Metals are sonorous, non-metals are not sonorous. Metals are good conductors of heat and electricity, non-metals are bad conductors of heat and electricity. But like metals, in the case of non-metals also, some non-metals show some exceptional properties. What are they? They are For example, metals are hard. The only non-metals are not hard, but diamond, one allotropic form of carbon, it's the hardest material in the universe. Do you know what I say? Metals are hard, non-metals are not hard, but one allotropic form of carbon named diamond, though it is a non-metal, it is the hardest material ever known. Similarly, metals are good conductors of heat and electricity. Non-metals are not conductors of heat and electricity. But one form of carbon, one allotropic form of carbon named graphite is a good conductor of electricity. So you have to remember the only non-metal which conduct electricity is graphite. The hardest material is diamond. The only non-metal which found in liquid state is bromine, Br. The 17th group 11 halogens, chlorine, bromine, iodine. The bromine is found in liquid state. Non-metals are non-lustrous. Lustrous means the shiny appearance on the cut end of surface. When we rub the surface with a sandpaper, a shiny appearance is produced. The non-metals are non-lustrous, but in the non-metal, iodine is lustrous. That means it has shiny appearance. These are almost the physical properties of metals and non-metals. You have to read the textbook, and those elements, those metals and those non-metals, which shows some exceptional properties, will remember. Similarly, if you learn or study these properties by reading several times, you may difficult to remember it, but first you have to collect some metals from your surroundings. Which metals you can collect from the surroundings? Iron nail. Similarly, aluminium. Cooking vessels are aluminium. Gold. It is in your gold ring. It's your hand. Iron, aluminium, gold, silver, copper. Then you collect it. Then you list the name of the metal, symbol of the metal. Then you point out the main properties. Then you never forget it. Similarly, the non-metals, you all know that non-metals are either in the solid or liquid or gaseous. In gaseous state, we can see the air. What are the non-metals? Which are the non-metals found in the air? Main content is nitrogen, then oxygen, hydrogen. Similarly, the inert gases, we can't see it because they are the gaseous. Similarly, the other non-metals we can touch and feel is which are iodine, carbon, bromine, sulfur. You collect this up. If you don't get it, it is easy to get these non-metals. But only one non-metal, which is your carbon. Carbon is easy to collect it. Carbon or coal. You have to study coal. The lower classes is a fuel for the train. Used to train the airless trains. Now, then diesel. Now it is electrical engines are used in trains. The coal is used as fuel for burning the engine of producing energy. By burning coal, we will produce energy, and with this train will you will travel. Then, now, today, we have just pass on to study the next topic, the chemical properties of metals and iron. That's more important. Chemical properties. First we have to, the earlier first class I told you that the general classification of elements are metals and non-metals. Chemically, what is the main difference? Metals, while take part in chemical reaction, it gives electrons, it loses electrons and become positive ions. On the other hand, non-metals, while take part in chemical reaction, it accepts electron and become negative ions or negative ions or negative anions. Now that's the main difference. Chemical difference is metals donate electrons, non-metals accept it. Now we can study the chemical properties one by one. The chemical properties. One, reaction with oxygen. With oxygen. The previous class we have learned that magnesium, when burns in oxygen, it produces magnesium oxide. In generally we can recognize that metal plus oxygen gives metal oxide. Metal plus oxygen gives metal oxide. Magnesium burns in oxygen to form magnesium oxide. Similarly, copper burns in oxygen gives copper oxide. Copper never burns, but what happens? On heating copper for a long time, a black color is appeared on the surface. When copper heating, you know that in your home there is a copper cooking vessel which is made of copper. If you observe closely, there is a black color on the outer side of the copper cooking vessels. Copper on heating, it is copper of black copper. Similarly, sodium when burns in oxygen, there is no need to burn sodium. If sodium is exposed to air for some time, what will happen? It combines with oxygen to form sodium oxide. This sodium oxide, when dissolves in water, it produces sodium hydroxide. Sodium hydroxide. So, potassium oxide when burns in oxygen, potassium when exposed to air, it combines with oxygen to form potassium oxide. This potassium oxide dissolves in water, potassium hydroxide is produced. These sodium hydroxide and potassium hydroxides are alkaline in nature. They are alkaline in nature. Likewise, aluminium on strong heating, aluminium oxide is formed. This aluminium oxide has a special property. Aluminum oxide and zinc oxide, they have a dual behavior. What's a dual behavior? DUAL, dual behavior. Dual behavior. DUAL. What is the dual behavior? Aluminum oxide and zinc oxide. What is the dual behavior? Aluminum oxide and zinc oxide react with the acids as well as bases to form salt and water. All other metallic oxides except aluminum oxide and zinc oxide. Metallic oxides are basic oxides. They react with acid solution. But aluminum oxide and zinc oxide, for example, aluminum oxide react with hydrochloric acid to form aluminum chloride and water. Aluminum oxide react with the hydrochloric acid to form aluminum chloride salt and water. Similarly, aluminum oxide react with the sodium hydroxide to form sodium aluminate and water. Please look here. What is the peculiarity about aluminum oxide? Aluminum is a metal. Generally, aluminum is a metal. It combines with oxygen to form aluminum oxide. This aluminum oxide reacts with the hydrochloric acid to form aluminum chloride and the salt named aluminum chloride and water. The same aluminum oxide reacts with the base sodium hydroxide to form a salt named sodium aluminate and water. What was the peculiarity here? Aluminum oxide reacts with both acids as well as bases. That is it has a dual behavior. There, dual means two behavior. All other metallic oxides react with only the acids only, not bases. So, aluminum oxide and zinc oxide are named as amphoteric oxides. Amphoteric oxides. You have to remember the name amphoteric oxide. Now we are discussing about amphoteric oxides. What do you mean amphoteric oxides? Amphoteric oxides are those which react with both acids and bases to form salt and water. So you remember that term amphoteric oxide. Amphoteric means are those oxides which reacts with acids as well as bases to form salt. Such oxides are called amphoteric oxides. Can you give examples? Aluminum oxide and zinc oxide. Aluminum oxide is known as amphoteric oxide. Why? Aluminum oxide reacts with the Similarly, aluminum oxide reacts with the bases to form salt and water. So, aluminum oxide is known as amphoteric oxide. Similarly, zinc oxide is also known as amphoteric oxide. Why? Zinc oxide reacts with the hydrochloric acid to form zinc chloride and water. Similarly, zinc oxide reacts with the sodium hydroxide to form sodium zincate and water. So, zinc oxide is also known as amphoteric oxide. Why? Zinc oxide reacts with the acids as well as bases to form salt and water. They have a dual behavior. So, they are called amphoteric oxide. So, you have a clear idea about amphoteric oxide and examples. Now, we can similarly answer them anodizing. Anodizing. What do you mean anodizing? If you purchase any aluminum article or aluminum vessel or aluminum plate from the shop, it has a shiny appearance. Aluminum plates, aluminum vessels, aluminum pots, anything, any material which is made by aluminum, when you purchase from the shop, it has a shiny appearance. If we kept it in our home or used for some days, its shiny appearance disappears. The color becomes dull. What happened? Aluminum, when exposed to air, aluminum reacts with the oxygen present in the air to form aluminum oxide. It is formed as a protective layer, as a coating on surface of the metal. It has a protective layer. Aluminum oxide is acts as a protective layer on the surface of the metal. So, the metal inside the coating does not happen and does not enter into further reaction. So, this aluminum coating, what is the material on the surface of the aluminum coating? Aluminum oxide. The metal is protected inside the coating. Then, scientists made experiments how to improve the thickness or increase the thickness of this coating. They succeeded in increasing the thickness of the coating, aluminum oxide coating on the surface of the metal by the process named electrolysis. This process is known as anodizing. What do you mean anodizing? Anodizing is a process for increasing the thickness of the oxide coating of the metal. Anodizing is a process of increasing the oxide layer, increase the thickness of the oxide layer of the aluminum metal by electrolysis. In electrolysis, aluminum is used as the anode and sulfuric acid is used as the electrolyte. After electrolysis, the oxygen liberated at the aluminum anode formed a coating and its coating, the thickness of the coating was increased. This aluminum oxide coating has a special property. It has the capacity to absorb colors. It acts as a dye. It can absorb different colors. So that is we can see that when we can in shop there is different colors of aluminum vessels, plates, etc. How we can do it? By the process anodizing, a aluminum oxide coating is formed. This material is then put into different colors. This aluminum oxide has the capacity to absorb different colors. Then, what is the point you have to remember in your mind is what? Three things. What are they? Aluminium, when exposed to air, this aluminium reacts with oxygen to form aluminium oxide. Today itself, you go to the kitchen and take an aluminium vessel, then you rub it with the sandpaper. If the coating is removed from the aluminium vessel, they have a shiny appearance. The coating is removed. This aluminium oxide coating is formed naturally if we place the aluminium vessel in open air for some weeks, for some days. If the aluminium vessel is placed in open air for some days, a natural process takes place. What is natural process? Aluminium metal reacts with the oxygen present in the air to form aluminium oxide. It acts as a protective layer. The metal inside does not happen spoiled then. But then what is anodizing? Anodizing is the artificial method for increasing the thickness of this aluminium oxide coating. Artificially, the normal aluminium oxide coating is formed if we place the aluminium metal in an open air. It takes days or weeks, but by electrolysis, we can artificially form a coating on the wet surface of the aluminium. This artificial method of forming aluminium oxide coating on the aluminium metal surface is known as anodizing. You understand? APA metal, or this what is artificial method? Electrolysis. On electrolysis, aluminium with which material we can need a coating, it is act as the anode and sulfuric acid as the electrolyte. Then after electrolysis, within minutes, a thick aluminium oxide coating is formed on the metal. It can absorb colors, it acts as a different colors can be produced. This is the difference between this is what you do anodizing. Artificial method of the process of artificially increasing the thickness of aluminium oxide coating on surface. Generally, it takes few minutes. We can quickly increase the thickness of the aluminium oxide. This is the reaction with oxide. Other metals like gold and silver, if you kept it for a long time, it does not react with oxide or not oxide. So, its color never fades. So, gold is used for making ornaments. Gold is used for making ornaments. Why? Its yellow color never fades. Its yellow color never fades away. Why? If we kept the gold metal or gold ornaments for a long time in air, it does not react with oxygen. Similarly, silver also. Here, silver does not react with oxygen, but in the case of silver, there is a problem. Do you know what is it? Silver does not react with the oxygen present in the air, but silver reacts with the hydrogen sulfide present in the air and a black coating of silver sulfide is formed. It does not react with oxygen. We can pass on the next to be reaction with water. With water. The reaction of metals with water can be classified into four. One, reaction with cold water. Reaction with cold water. Sodium and potassium. Sodium react with the cold water to form sodium hydroxide and hydrogen. Similarly, potassium reacts with the cold water to form potassium hydroxide and hydrogen. The metals react with the cold water. Then the second type is metals react with hot water. Calcium also reacts with the cold water. When calcium reacts with the cold water, calcium hydroxide is formed. It acts as a protective layer that the reaction is not very severe, not very active. Similarly, the reaction with the hot water. Magnesium reacts with the hot water to produce magnesium hydroxide and hydrogen. Magnesium hydroxide and hydrogen. The third category is reaction with the steam. Aluminium and iron. Aluminium reacts with the steam to form aluminium oxide plus hydrogen. Similarly, iron also reacts with steam to form iron oxide plus hydrogen. Aluminium and iron reacts with steam to produce their corresponding oxide and hydrogen. The fourth category is those metals which do not react with water. So, the metals react with water. Now we are discussing about metals with water. The reaction between metals with water can be classified into four. What are they? Those metals which react with the cold water. What are they? Sodium and potassium. Second category, those metals which react with hot water. First, cold water. Only highly reactive metals can only react with the cold water. Then the metals which react with hot water. For example, magnesium. The third category, the metals which react with steam. What are they? For example, aluminium and iron. What is fourth category? Metals does not react with either hot water, cold water or steam. What are they? They are gold and silver. They does not react with water. Then we can pass on to the next with the acids. The second category we have seen that metals react with acids to form salt and water. Magnesium reacts with hydrochloric acid to form magnesium chloride and magnesium reacts with sulfuric acid to form magnesium sulfate and water. Similarly, zinc reacts with hydrochloric acid to form zinc chloride. Zinc reacts with sulfuric acid to form zinc sulfate and hydrogen. Generally, metal plus acid gives salt plus hydrogen. Salt plus hydrogen. You have to remember. But in this case, as special case, we have always learning about metal plus either hydrochloric acid or sulfuric acid. There is no discussion about nitric acid. Why? We have not seen that magnesium or copper or any other metal does not, in the case of zinc, the reaction about nitric acid is not talking about anything else. Why? Nitric acid is a strong oxidizing agent. Nitric acid is a strong. So, whenever hydrogen is produced, nitric acid oxides the hydrogen to water and it getting itself reduced to N2O, NO2, NO, etc. Do you know what I say? Zinc react with hydrochloric acid and sulfuric acid. Zinc react with sulfuric acid to form zinc sulfate and hydrogen. Zinc react with hydrochloric acid to form zinc chloride and hydrogen. But there is, we don't learn about zinc react with nitric acid to form zinc nitrate and water. Why? Zinc react with nitric acid to form zinc nitrate and water. The zinc nitrate and hydrogen. Why there is? When zinc react with nitric acid, zinc nitrate and hydrogen are produced at the same moment, at the same instant. What happened? The hydrogen is oxidized to water and getting nitric acid getting itself reduced to nitrogen oxides. So, nitrate salt is not formed there. Do you know what I say? Why zinc does not react with nitric acid to form zinc nitrate and hydrogen? Or nitric acid does not react with the zinc to form zinc nitrate and hydrogen. Why? Because nitric acid is a strong oxidizing agent. What's strong oxidizing? What happened? Oxidizing agent. What's oxidation to reduction? Oxidation means addition of oxygen. Oxidizing agent means it you put out the reaction. What happens when nitric acid is happening? What is the special property of nitric acid? What is the peculiar property of nitric acid? Nitric acid is a strong oxidizing agent. HNO3. HNO3 is a strong oxidizing agent. So what do you do? As soon as the hydrogen is produced at the moment, hydrogen is oxidized to water. Then what happens in nitric acid? It itself getting reduced to hydrogen. Yet, magnesium and manganese reacts with the dilute nitric acid to form hydrogen. This is the exceptional case. You have to remember it. Then one more thing you have to is what is the aqua regia. Do you know what is the aqua regia? Aqua regia. Aqua regia is a mixture of two acids. What are they? Nitric acid and hydrochloric acid. What is the importance of it? It dissolves gold and platinum. Gold and platinum never dissolves in any kind of acids. So, they have made a mixture named aqua regia. Then, do you have a clear idea about aqua regia? It is a mixture of hydrochloric acid and nitric acid in the ratio 3:1. Hydrochloric acid is to nitric acid in the ratio 3:1. That means hydrochloric acid 3 volume, nitric acid 1 volume. Hydrochloric acid 3 liter. If 3 liter hydrochloric acid is taken, 1 liter nitric acid is taken. This mixture is known as aqua regia. What is the importance of it? It dissolves gold and platinum. So you have to remember these two things. What are the two things? What do you mean by aqua regia and what is its importance? Aqua regia means it's It's a mixture of hydrochloric acid and nitric acid in the ratio 3:1. You have to remember that if you return HCl is to HNO3 in the ratio 3:1. If you return the opposite nitric acid is to HCl, but here also you have to change the ratio. That means you have to always hydrochloric acid 1 volume and nitric acid 3 volume. HCl is to HNO3 means 3:1. HNO3 is HCl is 1:3. This mixture is known as sulfuric, and its importance is it dissolves gold and platinum. Then one more property in your textbook, the chemical property regarding the metals. The more reactive metals displaces less reactive metal from its source. The second chapter, we have also seen that there are 4 types of reactions. What are the 4 types of reactions? First, combination reaction. 2 or more elements combine to form a compound. Combination A plus B gives AB. The second type of reaction is decomposition. AB is only a single reactant on heating decomposes to give 2 or more products. This is decomposition. Combination and decomposition are just opposite. The third type reaction we have studied is displacement reaction. One component displaces, one constant displaces other constant from its source. The last we have studied that double displacement reaction. 2 substances interchange their constants is known as double displacement reaction. Now here we have to study about displacement reaction. That means that copper sulfate is taken in a test tube and an iron body is inserted. What happened? Copper sulfate is taken in a test tube and iron body or an iron is inserted. What happened? These ions puts out copper and takes place of copper. Then what happened? FeSO4 plus Cu. Here 2 metals. What are they? Iron and copper. Iron is more reactive than copper. Then what happened? The more reactive metal displaces a less reactive metal from its form. Then there is another question: how we can compare the reactivities in chemistry? In the case of metal, we can in the next episode we are going to study about the reactivity series. The reactivity series we can compare the reactivity more reactive element to the less reactive element. Out of 118 elements, there is no 2 elements which have the same reactivity or the same property. In the universe, we can see that program for human beings. No 2 human beings are alike in all properties, in all characteristics. Similarly, in all their contexts. Similarly, here only 118 elements. Out of this 118 elements, no 2 elements or no 2 metals are alike in every properties or a reactivity. So, one metal is slightly more reactive or slightly less reactive than the other metal. This reactivity can be experimentally proved by the scientists and given to us for study. This is known as reactivity series. We have to learn the reactivity series step by step. Then only we can answer these questions. On here is the iron and copper. We have to learn. We know that which is more reactive or which is the understand. Then only we can answer these type of questions. So in this session we have to learn. We will learn what are the things we have learned. First, metals. In the case of chemical properties of metals, what are the ones? Metals with oxygen. Metals with the oxide. Second thing, what I say? Metals with the water. Third, metals with the acids. Fourth, metals with the displacement reaction. More reactive metal displaces less reactive metal from its form. Among the terms, what are the terms you have to learn here? First thing you have to learn amphoteric oxides. What do you mean by amphoteric oxides? Amphoteric oxides means which reacts with both acids and bases to form salt and water. Other oxides are not either only react with acids only or react with the bases only. These amphoteric oxides only react with both acids and bases to form salt and water. For example, aluminum oxide and zinc oxide. First, you have to remember the definition and example of amphoteric oxide. Amphoteric oxides are those which react with acids as well as bases. Example, aluminum oxide and zinc oxide. Then you have to come to another term, anodizing. Anodizing is means artificial process of increasing the thickness of the oxide layer of aluminum. Increasing the thickness of the oxide layer of aluminum by artificial. This is known as anodizing. The third thing you have to remember is aqua regia. Aqua regia means it's a mixture of hydrochloric acid and nitric acid in the ratio 3:1. It dissolves gold and platinum. Then we have to go on to study the reactivity series. We can take it to the next class. Let us wind up our class today. Okay, thank you all.